Sure, people are still getting back here, but I think we can get started in the interest of time. So thank you, Daniel, for your time and for presenting here. I will let you start now. Thanks.
Okay. So good morning or afternoon to all of you, depending on where you are. So I'm Damien. I'm an ontologist at Flybase, and I'm also one of the maintainers of the Protege ontology editor, which is a tool that you have started to learn to use with Sabrina in the previous session. So in this short talk, I will give you an update about some of the last features some of the new features in the last major version of Protege, which was released a little bit earlier this year. Before I go into that, a little bit of history. You've seen before in Darren's talk how the OBO Foundry dates back to a little bit more than 20 years. Actually, in the case of Protege, it has even a longer history than that. Protege's history can be traced back to some knowledge management and problem-solving tools first written in the 1980s, with the very first version of Protege, which we now call Protege 1, being released in 1988. So since then, the program went through several complete rewrites, leading to the version that we are now familiar with, and which was called at the time Protege 2000. So to illustrate, we went from this interface back in the 1980s on the left to the Protege 5.6 that you have just seen in the previous talk. So there is no take-home message here, but I just wanted to stress the fact that when you are using Protege, you are using a tool with nearly 4 decades of history behind it. So for some of you, you may even be using a tool that is older than yourself. So one of the recent changes in Protege is not actually a change in the software itself, but a change in the way it is developed. So Protege has now switched to a community-based development model. So this community has several points of contact, which are regrouped in this slide. Slides that you will be able to find as for all the other slides from all the other talks in this tutorial. So probably the most important point of contact is our bug tracker on GitHub, which you can find here. But you can also pop up on the Protege channel on the OBO Slack, or you can also use one of the 2 mailing lists that are provided by the original groups of maintainers at University of Stanford. So what is new in Protege 5.6? By far, the most important changes in Protege 5.6 are purely technical ones, which may not be immediately visible to the users, but for some of them at least, they deserve a few words. One of those changes is the fact that, one of the changes is the fact that Protege can now run natively on Apple Silicon machines, so Mac computers using Apple-made CPUs instead of Intel chips. So from now on, Protege is no longer relying on what Apple calls the Rosetta emulation layer, but instead run natively on the Apple-made chips, which means that for users of such machines, compared to previous versions of Protege, you should observe significantly increased performances. Thank you, Michael. Another important change is the switch from All API version 4.56 to 4.525. So this is normally something that users should never have to worry about or even be aware of. But in this particular instance, this upgrade for 456 to 4525 is important because several of the all serializers that Protege is using to save an ontology on disk behave differently between those two versions. And what this means in particular is that you should avoid the situation where if several people are working on the same ontology, some people are still using Protege 5.5, so the previous major release, while others have already switched to Protege 5.6. If you are into this kind of situation, this is very likely to create some huge mess when you start having to deal with pull requests made by people using different versions of Protege. So basically, all editors working on the same ontology should either remain on Protege 5.5 if you have a compelling reason to do so, or should all switch to Protege 5.6 if that's not already done. So another change is in the way and even in the need of configuring Protege's memory settings. So several of the ontologies that we are routinely working with in OBO are quite large enough that in order to work comfortably with them with Protege, you need to make sure that Protege has enough memory allocated to it. And the good news with Protege 5.6 is that nowadays, Protege has a default configuration that should be sensible enough that most users should not need actually any special configuration. So basically, the default amount of memory that is now allocated to Protege is dependent on the total amount of memory that is available on your machine. And so basically, if you have less than 4 gigabytes, which incidentally is a very small amount of memory to have to work with some of our ontologies, but if that's what you have, then you might have to deal with that. So if you have less than 4 gigabytes of total memory, then Protege will use up to 1 gigabyte by default. If you have less than 8, then Protege will use 50%. And up to, if you have more than 16 gigabytes of memory, then Protege by default will use 3/4 of that. So for example, if you have 32 gigabytes of memory, Protege by default will run with 24 gigabytes of memory allocated to it. So this should mean that most users should not need to manually configure Protege to change the amount of memory that is allocated to it. If you do need to change the amount of Protege, the amount of memory allocated to Protege, there is no common mechanism to do that across all platforms, Windows, Linux, and macOS, which is this file called gvm.conf, which you can find either in your home directory under the directory .protege/conf/gvm.conf, or directly within the directory where Protege is installed. And that file uses a simple syntax based on the key value pairs, where the values that you might want to modify, if the default setting is not suitable for you, is the value called the max heap size, which is the maximal amount of memory allocated to Protege. But again, you should not need to do that in most cases. So just try to run Protege, and you should find that it is running with a memory setting that should be suitable in most cases. Now, as before, Protege 5.6 is provided bundled with a set of default plugins. The main change here is that in Protege 5.6, the ELK reasoner that we Sabrina talked about earlier is now installed by default. You know, so if you have used Protege 5.5 before, or even some older version, you might remember that you needed to manually install the ELK reasoner. So no, you no longer need to do that. So no, the ELK reasoner is already installed and ready to use as soon as you install Protege itself. And while we are on the issues of plugins, and even though this is not actually something that has changed in Protege 5.6, but just a quick word on how to actually install plugins if you need to do that. So there's basically two ways. There's manual setup, in which case you have to manually download the plugin from whatever source you get it from, and then place a plugins file either into the directory .protege/plugins in your home directory, or in the /plugins directory in the directory where Protege itself is installed if you have rights to put files in that directory, depending on your operating system and your configuration. So that's manual installation. Automatic installation can be enabled by enabling this setting called auto update in Protege settings. When this setting is enabled, what will happen is that every day, the first time you start Protege every day, Protege will look up a file in a central server where we have a list of all known plugins. It will compare that with the list of plugins that are currently installed on your machine, and it will propose you to install any plugin that you don't already have. And at the same time, it will also propose you to update any plugins that you might already have, but in a slightly outdated version. So that was for plugins. Now we get to what is probably the most important user visible change in Protege 5.6, and one change that has a big potential to make the life of many users considerably easier. So that's what we call the support for ID range policy files. So something that might not have been described or touched in the previous talk is that when you need to create new terms or new relations or new data types in an ontology, before you can do that, you need to configure Protege so that it knows which IDs it can use to create those new terms. And the way it was done, and the way it can still be done nowadays, is to fill this particular dialog settings here, where you configure. Normally, when you start contributing to an ontology, you should be assigned what we call an ID range, which is basically a way of saying that any terms that you create must have an ID within that particular range. And that's a way to avoid different contributors creating terms with clashing IDs. But of course, for that to work, Protege needs to be aware of the range that has been assigned to you. And in the previous version of Protege, you needed to manually configure Protege. You needed to manually tell Protege, this is the range that has been assigned to me. So whenever I want to create an ID, please use an ID within that range. Which was perfectly fine as long as you are only working with one ontology. But if you're working with several ontologies in parallel, this becomes a little bit of a hassle, because you might very well have a different ID range for all those different ontologies, which means that every time you switch from one ontology to the next, you need to reconfigure Protege to reset your ID range for the ontologies that you are about to edit. So that is what you no longer need to do with Protege 5.6, because now Protege 5.6 can use what we call those ID range policy files, which look like the one that you can see here on the right, which is basically a file that formally describes the ID ranges for all known editors to an ontology. So now, when you become a new contributor to an ontology, the person that is responsible for maintaining this ontology will not only assign you an ID range, but it will also update the ID range file. And when you open the ontology in Protege, Protege will automatically detect the ID range policy file if it exists. And if it detects this file, and if it finds an ID range corresponding to your username, it will automatically use it so that you don't have anything to do. And if it cannot find a range allocated to a name that corresponds to your current username, then you will be prompted, and yes. So if it cannot find a range allocated to a user whose name corresponds to your username on your machine, then it will prompt you, it will show you this screen where it will show you all the different ID ranges that it knows about as described in the ID range policy file, so that all you have to do is to find the one that is allocated to you and just click on use selected user. And that's it. Protege will, from now on, use the ID range that has been assigned to you so that you don't have to manually configure Protege to say, my IDs start at, for example, ID 58,000 and run up to 60,000 or so. You can still do that manually if you want, but as long as you have an ID range policy file in the ontology that you are working with, and normally most ontologies, especially most of the OBO ontologies, have such an ID range policy file, you should no longer need to worry about manually setting your ID range. So now for the rest of the talk, I will quickly go through some of the other user visible changes. So they are much less important. Actually, before I continue, can I get a quick check from the chair about the time? From what I can see, I should have something like 2 minutes left. Is that correct?
Yeah, that's all right. Just take your 2, 3 minutes, 4 minutes, whatever you need.
Okay. So one of the changes here, and I basically don't need to say anything more. That's what you can see on the slide. Basically, Protege is able to recognize more types of short identifiers and render them as clickable links. So you can see, for example, on this slide, identifiers to mesh, to some other ontologies such as BTO or RVBT, identifiers to digital object identifiers, identifier links to Wikipedia. They are all recognized by Protege as something that you can click on so that you can be redirected to whatever resources lies beyond those identifiers. Another small change is that by default, Protege will no longer show obsolete entities. So any entity that has been declared as being deprecated will still be present in the ontology, but no longer shown in the entity trees. So if you want to see those entities, you need to enable here display deprecated obsolete entities. So that feature has always been there. The only difference is that no, it is disabled by default. Another small change is we have a slightly more sensible behavior in the class expression editor. So if you are in the case where you have in your ontology two terms that have the same label, one defined in the ontology that you are currently working on, and another in an ontology that is imported in your ontology. So, for example, this is the case that we have here in the Drosophila anatomy ontology. We have a term for cell, which is a fly-based term for fly cell, which is just called cell. And we also have another term for cell here, which is a term coming from the cell ontology, which is a generic term for all biological cells. So the fact that you have those two terms with the same label could be a little bit annoying in previous version of Protege when you needed to make a reference to one of those terms in the class expression editor. Now, the class expression editor will make sure that if you are in this case, the class expression editor will assume that most likely if you want to make a reference to the cell term, most likely you want to make a reference to the cell term that is defined in the very ontologies that you are working on right now. So for example, in my case, I want to make a reference to the term from the fly-based anatomy ontology and not from the term from the cell ontology. And that's the default behavior now of the class expression editor. And yes, there's also some small change about the way you can now configure more precisely how entities are rendered in various places, such as notably the entity tree. But let's not enter into that since I'm already out of time. So that will be it for now. If you have any questions, I will invite you to ask them in the at the end of this session, where we have a dedicated slot for more questions.
All right, thank you very much, Damon. I didn't get the last bit about questions. So you said you're taking questions now, or we're skipping questions? So.
I mean, I don't mind taking questions. No, I mean, that's up to you as chair to decide. If some people have some questions, no, I'm happy to answer them immediately.
No questions? Yeah, I don't know if anyone online has questions for Damien.
I don't see anything.
Yeah, if not, well, you can always ask later. Thank you, Damon, for the very good overview of the Protege. Thank you very much. And now we'll proceed to the next talk with Anita talking about the OBO dashboard and quality control in OBO. So, thanks.
Thank you, Thiago. Yeah, so as you said, yeah, I'm Anita, and I am the maintainer of the OBO dashboard. So if you have any questions, maybe I am the good person to ask about the dashboard. So yeah, a bit of an introduction here. So yeah, as Darian said in the first presentation, to talk about all the ontology, and then the how many ontologies we have, and then how it's hard to make everything work in harmonize everything. So this is as Darren said, also this is just one more tool that we offer to the community to engage the process of facilitating interoperability. Sorry. So yeah, so the reality what we have, because we have more than 200 ontologies, of course we have many variations. So many ontology developers decide to use, for example, different annotations for the same, I mean, to link the same, for example, GitHub tickets. Some of them use the IAO annotation, the term tracker item. Others can use the RDFS C also. And another example is some of them also can use the term editor, or use the terms contributor annotation to give the contribution of the new term created in the ontology, and also the obo in our date versus the term state to add some date, the date creation of the term. And then this is not a just a small example. We have also the versioning habits that we can, for different ontologies. Sometimes we have the date as the year, month, and date, or the other version date is start with date, month, and year. So there are some differences there. And then also how it's the representation. and then the interpretability of the cross-reference and all the mappings. It is also a big difference in how active and responsive are ontologies to deal with requests. Some ontologies are well defined using how the pull requests and using GitHub issues, and then others is just we don't know actually. So it can be really confused, all the ways, all the possibilities to have a new request for the ontology. And then for the prefix, it's also another big difference that sometimes people define the query as just a lowercase, and then some other using underscores and everything. So this is the reality that we have now, that is everything thinks their way, it's the good way. So yeah, and then we have the OBO principles, that is just provide a map towards the open interoperable ontology. So as Darren said, I'm gonna refrain many times Darren talk about the OBO principles and then the OBO Foundry. So we have at the OBO Foundry defined many principles to have some alignment after many discussions, of course, from the community. So we have some our favorite principles here, as for example, the open, that it must be openly available to be used by all without any constraint. This is the first and more important principle. We also have the relations, that we should only use the relations ontology, that is our upper ontology for the relations. And then I also choose here the users principle, that is the ontology developed should document that the ontology is used by multiple independent people or organizations, because it's important to create an ontology that it's widely used. And then I'm going to later I'm going to share how you can add new usage for your ontology inside the OBO Foundry. Yeah. So as the OBO dashboard is nothing than just operationalize the OBO principle. So it just automate all the principles and checks for the principles. And then because all the interpretation of the principle is always not clear. So for example, here, as I said, the first principle about the openness, and then some people must just say that I made a note in my README, and then say, okay, it's open, you can use it, but then it doesn't make clear to use a license and a proper license and everything. So also another example for the user principle, that is just give an email, say, of course this this database is using my ontology and everything. So it's just formalize all the principles. So the dashboard is here to automate and check all this all the principles. So here is basically this is the dashboard. So we have also an article that it's write out everything that it's important, and then really in detail. So I recommend you to have a look into that if you want to really know about all the principles and the dashboard. So I'm going to do a quick demo. So I'm gonna just give a quick overview and then show how to what is being checked with the automated checks that is implemented in the OBO dashboards. Show the reports, the different reports, and then also fix some errors in the dashboards. So here is you can access the dashboard here. You can, all the columns here are the principles that we check, and plus the robot report that we also generate for each ontology in the OBO Foundry. So yeah, we have many. And then, for example, here, if we click on the column, we can go to the principal documentation. So we can read all the purpose, the recommendations, and then the implementations, how we can add this openness to our ontology and everything, and examples really well documented. And then for each principle, we can check here. Also, if we go, for example, in one ontology here, we will have the same principle listed here, and also the easy now to have the automated check. That is, we can just click here and check what is actually implemented in the OBO dashboard. That is what it says that is passed or failed or just missing something. So here is well documented all the checks in the dashboard that is written in Python, by the way. And here all the comments also. And then for some of the principles, we have a specific report. For example, this URL, it's some missing, no invalid URL. Yeah, I think it's just some bug here. So yeah, and then also I think there is also one specific report for relations. Let me just go back and find one ontology that has an issue with the relations report. So for example, the relation principle, it says to use only the RO ontology, but here we see that many of the relations are from the ontology itself. But then also this also shows that actually ontology are relations, relation defining the ontology shares the same label as in this the ontology here, the relation. And then would be good actually for the ontology to use the one that is already available, then create a new one if it's the same meaning. So these are the reports, and then also we have the verbal reports that you can also check here. Click here, and then check here the full list of the queries, and then the checks also available in the verbal report. let's go back to, yeah, and then here we have the robot report, all the results from the list of queries that I showed before. So now I'm going to, yeah, I've checked before, and I see that the ontology, this ontology here is actually missing the use it. And then I'm going to show you how to add that easily, that we can easily add that to the metadata ontology in the OBO Foundry. So here we can check here the plurality of users, the principal. We can check here the implementation. The ontology develops must provide links, citations to publicly available evidence of use within your ontology metadata file, as given below. So here's an example of the entry that you need to add in the. Sorry, I just got confused. But this is another ontology actually that we are gonna add. The usage I'm going to add into the ICBO taxon. But so this is the metadata that the principal says to add the usage. So we go here to the ICBO taxon. And we did here, and then just go. I have already did some text here to quickly add the usage. So that's it. So yeah, I found this database that are the Yomini epitope database and tools that use actually ICBO taxon. So I can just link this website here as a usage of the ICBO taxon. So yeah, that's the text here. And I just want, create a new branch, and then add usage. And then we'll create a pull request, and then someone is going to reveal, and then in the next OBO dashboard release, we can pass this check here for also this one is also missing the ZFS, but then we can check the ICBO taxon is also missing the usage. So next time, this is the only thing that is missing, so the only error, and then will be passed next time. So another fix, easy fix, actually, is to add the license to the ZFS. As you can see, it's missing the license, but in the OBO Foundry website, we can see that there is a license here, but they are in different places. So we need to make sure that everything is aligned. So for this, I just have here the ontology opened, and I will just copy paste there, and then and then next I'll just create a pull request, so then someone can review, make sure that everything is fine. Yeah, because we have many ontologies in this repository, we need to specify. Yes. So yeah, basically the dashboards helps all the ontology developers to check all if it's aligned with the principles, the OBO Foundry principles or not. Okay, so back to slides. So another use of the OBO dashboard is when an ontology representative submits a new OBO Foundry ontology, a new ontology actually, to be included in the OBO Foundry. So after the requester checks all the dashboard, and then pass all the basic metadata quality check, then our OBO reviewer will be allotted to review your submission, and then finally manually give you a recommendation, or if it's good enough for the OBO Foundry. Another yes, so this is the this is the new ontology request that you can check, everyone can check. So another use of the OBO dashboard is also it's as a template. We create a template so you can have a more customized OBO dashboard with only with your ontologies of interest, and then also you can customize the checks. You can add more checks specific for your ontology, for your set of ontologies. For example, we have the Monarch initiative ontology dashboard. So here is only the ontology that is important for the Monarch initiative, and also they can, as I said, add new quality checks using the robot report. So yeah, it's great. It's we have a dashboard, and now what? It's a good question. So we how to actually get people to go green? It's from now from the 1st January 2024, the OBO Foundry have decided that all the ontologies must go green, or otherwise actually it will be in a different visualization, and it will be not on top as we have now, but then this will show some also if the ontologies are really more recommended or not. And also we can help people how to fix the issues, like the training today, and then how to also build in the tools like a robot ODK, bioregistry, and queries. And also we we have some other projects that try to also work with this interoperability of the all ontologies that is the obo graph. There we have some of the obo ontologies all integrated in Sparkle endpoint. So this is all the checks make sure that everything can be well integrated, and also the obo principles are part of the fair. So we want also to be included, and then across all standardization efforts like the fair impact obo or LSE and many other projects. And then this is the just a feature in the Agro portal that shows the fair score for an ontology. So you can check here for your ontology how is your fair score. So it's also good. That's it. Any questions? Yeah, maybe for the end of the tutorial.
Thank you very much, Anita. I don't know, does anyone have questions for her about the dashboard? No questions here for the audience, but I do have a question with myself. So you mentioned that on the 1st of January, the ontologies need to be all green on the dashboard to stay in the OBO Foundry. How is this going to go? I mean, how will the people kick it out of OBO Foundry if there's some missing? How is this process planned if it is?
Yeah, the all green it's as our ideal world, but we actually at least we would like not to have the red, no reds actually, and then we want to help also to fix help to fix the issues that we try. We will also it will be available in the next OBO newsletter to say about this too, and then to make clear about this.
If I can just add to this, just so that there's no worries or confusion about what it means that you have to pass the dashboard. So as Anita said in her talk, it's really right now we are going to be quite gentle, and it will be really just a visual separation. So it's already been practiced for the past year or even 2 years that you have to pass the dashboard if you now enter or almost past the dashboard if you now enter with a new ontology, but not from the 1st of January 2024, your ontology will be visually separated if you don't pass the dashboard, which means that the ontologies that do pass will be favorably highlighted and promoted on the website.
Yeah, that's great. So thank you, Anita, and thanks, Nico. I think if anyone has any additional questions, you can bring to the chat. I guess now we will have Sierra talking about ChatGPT as per the updated schedule, if I'm right.
Yep, that's me. Can you hear me? Hopefully you can hear me.
Yes.
All right.
Yep.
So let's get this going. All right, so I think we're going to change gears a little bit now. You've just heard a whole lot about really successfully maintained and well-developed tools that are giving us a lot of help when we're developing ontologies, and we should rely on them very, very much as they come and ask questions about them because they're well supported. And I've gotten the privilege to just sort of go off on a tangent here and talk about ChatGPT as an experimental tool for use in OBO ontology development. So hopefully this is an interactive session and we can have some fun. I don't mind if you interrupt me and kind of remote control me if you're looking at a particular example and you want me to add something else to the chat window, I'm happy to do that. So I guess just really briefly, my background is in data modeling and software development. I'm a software developer in Chris Mungall's group. I'm currently working on LinkML, which you might have heard out of the last ICBO. It's the linked data modeling language and framework. We do a lot of work with standards and ontologies in our group. I also work for the Gene Ontology, the NCATS Data Translator, and Monarch Initiative. So I have a lot of experience working at that boundary between software development and model development with subject matter experts. And, you know, I'm not the only one that's looked at ChatGPT. I'm sure everyone in this talk has already seen some of it. I'm also not the best trainer. There's lots of good resources out there for you if you'd like to follow up. Hopefully I'll just spark your interest and you'll do some experimenting on your own. In particular, this top link has a very good tech tutorial. It's not too high level. It's not too detailed, I should say. The layperson could follow the tutorial, and it really gives you a sense of how to work with these large language models. We've also presented some of the work that I'll talk about today at various different conferences. Each of these boxes here is linked. So if you have access to the slides, you can click on them and see a whole lot more information. And on that note, there's a lot of people in our group that are working on this. So thanks to everybody who's doing that, especially Harry Caulfield and Martine Jokamak and Justin Harshad, and of course, Chris. So I think whenever I sort of talk about ChatGPT in the context of the work we're doing, I always give a little bit of background on how I even started using this. And I think a real key to learning a new tool for me is to just play with it. And I think as a software developer, I'm probably more used to doing that than maybe some other professions are, right? Like if I don't keep up with new technology, if I don't learn new things, then my career is going to be maybe shorter lived than others, because technology changes really quickly and we kind of have to adapt to that as we grow. And also as a software developer, we're constantly balancing new development, new tool development, and maintenance of old tool development. So any kind of tools that make us faster really do help us maintain, you know, sort of sanity and way of life and ability to make new tools, but also, you know, maintain the old tools as well. And so the way I started with ChatGPT is I really just tried to make it hallucinate, right? I think a lot of people do that too. And so the first thing I started with was just being kind of snarky and saying, can I get it to make up a syndrome? Because I work, again, at the boundary between data modeling and software development. I thought, well, you know, I'm not exactly a subject matter expert on diseases, but I can make ChatGPT hallucinate one. And so, you know, this field is changing very quickly. And so at the beginning, I was able to very easily make ChatGPT hallucinate this Kool-Aid man syndrome as a rare autosomal recessive disorder. At one point, I had it telling me that it was, you know, causing aneurysms and bursting blood vessels and all sorts of things, which is totally false and completely ridiculous. And it's not on chromosome 1, 5, and you know, et cetera, et cetera. But what it gave me was the ability to work with the tool and also sort of think creatively about how I would use it if it could do some work that wasn't so hallucinatory. And I should just note that over the course of the last 6 months, I can no longer get ChatGPT. Even if I try really hard to be a snarky developer, I can't get it to create fake diseases anymore. So this field is really evolving quickly. And it's, you know, just note that it's gotten a lot better too, just over the course of the last 2 or 3 months. So taking it away one step further than just this silly play time, you know, another tool besides ChatGPT that I use as a software developer every day is GitHub Copilot. It's also a tool that's trained on a large language model. And so if I'm writing my code and my routines and my methods, and I have Copilot installed in my integrative development environment, my IDE, it can auto-complete the code I'm writing for me. And, you know, it's not perfect every time, but it does give me a good idea of the standard conventions that are used for software development, and also has taught me things about how to write methods that I wouldn't have known before. Of course, it's just a tool, right? Everything has its downsides, and I do have to still be a human and maintain and watch what it's doing, or else it can get into trouble. But I've also used ChatGPT for helping me pick, you know, well-known words and phrases to make data models that are not only scientifically relevant, but precise and human readable. So a lot of our work is conveying the vast amount of biological knowledge we have in formats that people can pick up and read very easily. I use ChatGPT to help me with very routine script writing. So for example, I'm not an expert in pandas, but I know I need to manipulate some data in Python in a sort of tabular format. I can get ChatGPT to help me make some pandas data frames and act on them without having to consult the documentation for pandas and start from scratch and read the entire documentation. It's kind of like a very well-directed answer to my questions about the exact script I'm writing, and not about scripts in general, which is sometimes what you get back when you Google an answer that you're looking for. I also use it to explain error messages and functions. I mentioned at the beginning, you know, I might have to maintain software that's 12 years old, right? Or I might have to be tasked with migrating software that's 12 years old into a new language. And, you know, sometimes I'll take an entire method and stick it in ChatGPT and just say, explain this to me, and it does. And of course, I use large language models like Grammarly for all my online writing. It checks my spelling, it checks my grammar, it checks my tone. So I actually do use this a lot. And what I've found after watching those tutorials and, you know, experimenting it with myself, this is my son Connor, he's a teenager. And, you know, one of the things they tell us is that, you know, talking to this large language model and getting it to respond in a useful way and not in a hallucinatory way is kind of, you kind of think of it as talking to a really well-read teenager, right? So you want to give that teenager clear and specific instructions. They're going to try to get out of whatever you're telling them to do, but you got to give them clear and specific instructions. If you don't get the result you want the first time, you got to use different words to get better results. The second time, maybe more specific rules, maybe a longer explanation, maybe some examples. The way you write a prompt is really important. And also, these language models are going to rush to try to find you the answer, right? They're going to go as quickly as possible. And so if you put in benchmarks or in places in your prompt where you make them stop and think, it sometimes can lead to a better result. And all of this is found in those tutorials that I linked at the front too. So I guess the best way to look at this is really just to do some experimentation. And so I've put a few together that we can go through together on the call here, but if you have other things you want me to do, of course, just interrupt me. So the first one I have here is a use case that I have from the project I work on, the NCATS data translator. We're trying to bring together all this dispersed and diverse data from all of the biomedical communities that were represented, and we're trying to put a search interface over the top of that. And one of the sources that we kind of draw from is the SemMed semantic parsing of all of the results in PubMed, right? It's an automated tool. It sometimes makes mistakes. And so one of the things I have to do often is look at the results we get back from our tool and verify quickly, you know, have a 50 or 60 or 80 or 100 results and verify quickly that what we're returning actually makes sense compared to the publications that we're using as references. So one of those was, you know, can you find me the drugs that treat dentin dysplasia? You know, if my actually written algorithmic tool that I've developed, my search interface, returns me this publication, I can click on it here. Whoops, excuse me. Right, it gives me this publication. It's talking about dentin as a major component of teeth, and it's talking about a mouse experiment that they did. Let's just accept those. And it gives me a few genes, and it tells me, you know, what those genes do in this mouse experiment to sort of elucidate what dentin dysplasia is. And I'm not a biologist, again, I'm a software developer, and so reading really thick text like this is not my forte. So I just was experimenting, and I said, you know, given the following abstract text, right, summarize it for me in the, summarize it for me so that a undergrad could understand it, right? It's very simple. This is a well-publicized usage of ChatGPT to summarize text. Interestingly enough, that summary is almost as long as the text itself, if not longer. So I'm not very patient, and I said, and I'm going to just say, please do this summary in 3 sentences or less, right? I'm impatient. Okay, so now it's going to give me much smaller. So I've already done an iterative prompt development based on what it's given me back. I've said, you gave me a really, really long response. I was really looking for something short. Just do it in 3 sentences or less. So it's going to give me a small paragraph that I can understand as an undergrad biology student, right? So it says it's investigating the ACVR1 protein using mice. When it's missing, the molars have thinner dentin, and et cetera, et cetera. So it's already done a job of telling me right away how dentin dysplasia, or the loss of dentin, is interacting with the genes in the abstract. I can go further with that, of course, and I can say, can you please give me a list of the genes in the text in mouse nomenclature? Let's just see what it does. So it's going to pull out it, and it did an okay job. I don't think ACVR1 is actually in mouse nomenclature. I think it should be capital A and lowercase, but it did some lowercase here, and it could be that ACRV1, I would go back and check, is the human gene in the paper. You know, I can say, can you put these genes in a table along with an indication of whether they were in upregulated or downregulated. Right, so, and it immediately gave me that table. It talks about upregulation and downregulation, which in the paper, I think this is right. You can, of course, go back and read it for yourself. It already told me that it was not specified here in the paper, and that's actually an improvement over what used to happen. It used to be that it would just guess at this and hallucinate this answer, and now it looks like without me even telling it, it's going to return me something that it doesn't know, or it's going to return the fact that it doesn't know, it's not specified, which is great. Right, so why am I showing you this? Well, for me, this gives me, if I can do it manually, I know I can do it programmatically. So if I can interact with this tool programmatically, I can go through hundreds of abstracts very quickly, get a small summary, and extract sort of what ChatGPT thinks is the, you know, increased or decreased regulation of these genes. And, you know, depending on my level of trust of this resource, of course, that's what your next question is going to be. How can I trust this result? Well, I'll show you. There's other ways to get it to verify its results, right? But this is one use case. As I'm listening to the talks this morning, I'm trying to pull out information from those talks to see if I can get ChatGPT to do this quicker. So here, let me show this one here. Right, I don't think I can go through all of these. I might not have all the time in the world here. It says this one. Right, let's just start over. Okay, so can you give me all the obsolete terms in the Mondo disease ontology? And it's going to give me how to do it, right? And then it's going to, based on, so you can see I use ChatGPT a lot. And so it has a lot of history of dealing with me. And one of the things that I was trying to do to prepare for this talk was to write Sparkle. So it's going to assume that I want Sparkle because I'm still in the same, you know, it's recorded some metadata about me. You know, previously when I did this result, it gave me, so I'm just going to see if I can make it do it. So I don't want Sparkle. Please give me a Python program that I can run in a collab notebook, right? Oops, I misspelled notebook. Let's see what it does. Right, so it's telling me which Python libraries to use. It's giving me a pseudocode. It's giving me sort of like an example pseudocode of how to do that. It's telling me what to do in the collab notebook, and it's giving me some code that I can write. It's still giving me Sparkle. I like that. So I can show you the one it gave me earlier today. So it told me to install requests in my collab notebook. I did that. And then it had me, you know, paste in this. This is literally just code that it has generated, right? So it's saying, it's giving me a method in Python. It's giving me all of the code I need to put the Mondo ontology into a graph object. You know, I actually know about the graph object in RDF-lib, but you don't have, I mean, you don't have to know about that. You can just copy it into this collab notebook and try it, right? And so it's parsing it, it's going through it, and it actually does find all of the obsolete terms in the Mondo ontology. And that was, 3 sentences of my time, 3 sentences that I wrote to this tool, and I have a whole notebook that I can use to extract obsoletes. So, even if it's not, tailor your use cases, your mileage may vary, right? So tailor your use cases to things that you can verify. I like it when it writes code for me because I can easily verify that. I can look at the code, I can use my knowledge as a software developer to figure out whether or not it's doing the right thing. And I imagine you can do the same thing as if it's making ontology stuff. So another thing I saw from our Slack channel, the OBO Foundry Slack channel, was a user asking, I really want to know if I have this list of comma separated terms, I want to use the lexical matching algorithms we have in some of the software that we provide to find potential matches to existing ontology terms. So again, I just can't click on that anymore. So I just went in and did that with ChatGPT. And again, it's going to do this for me. I'm going to be able to put in that list. I'm going to be able to retrieve lexical matches, and off I go. I could do that for you. I'm not sure how are we doing on time. Right. So yeah, Nico, it doesn't. I don't have any definitive proof, and I haven't gone through and tried to test this out or read any information about whether it preserves information between chats. But what I can tell you is that in this window, I have ChatGPT open with my personal account, and it has all these different things. And then I have another account with just LBL. And in that account, the first thing it does when I ask it about ontologies is it gives me Python because I haven't used it as much. But in this account where I've asked it a lot for Sparkle, it gives me Sparkle. So no, I don't think that it's advertised as understanding your queries between sessions, but my colloquial interaction with the tool shows me that it does know me. It also is going to give me mostly pandas until I clear all these out, because again, I'm not a pandas expert. It's something that I want help with. So it's giving me a lot of pandas information. I know it's kind of crazy. Okay, so another thing I did was, as Sabrina was talking, she gave an issue in the Mondo repo that was, we want to add ClinGen xrefs to Mondo. So I did these 7 prompts while she was talking. Sorry, Sabrina, but you were just so nice to listen to. I just was doing this in the background. Again, I was paying attention to Sabrina and I was letting the tool do my work for me. So I said, using the Mondo disease ontology JSON file, can you return in a simple table a list of Mondo terms and the labels that don't have ClinGen refs, right? And so what I wanted to show you here with this is that, it's getting even more advanced. So with ChatGPT 4, and this beta work they have, you can actually upload. I don't know, you probably can't see my upload box here. Oh, hidden behind the Zoom. Is it gonna? Live demos, gotta love them. Okay, so here, what I'm gonna do is I'm gonna upload the JSON representation of Mondo to ChatGPT. And I'm gonna say, I've just uploaded the Mondo ontology in JSON, in obo-JSON format. So I'm being very specific. I'm telling it what I did, giving it clear instructions. I'm giving it a hint of what I'm doing by providing the entirety of the file, actually. Let's see, so our use case here was, right. The other thing I wanted to do is look through the ClinGen file, right? So I downloaded this other file with a bunch of ClinGen references, xrefs in it to Mondo. And the first thing I wanted to do is, can you provide me a simple list of Mondo terms that do not have ClinGen cross-references, right? And so this particular part of it is really interesting as a software developer, and I hope it's interesting for you too. But what it's doing right now is it's analyzing that file I just uploaded, and it's writing me code. I can show the work where I don't have to, about how it's interpreting the file. So it's actually spun up a server for me. It's installed Python on it. It has taken that file that I gave it and parsed it, right? And it's analyzing what the file is all about without me doing anything. I haven't done anything to this except put in the file. And it's trying to interpret what this file is all about. If I was smart, I wouldn't just leave my prompt so open-ended. I would take that prompt and say, it's in obo.json format. Here's the schema of this JSON file. Here's an example of what the stanza looks like. And here are the fields I'm interested in, the definition, the xrefs field, etc. It would make this process go faster, but you can see that that's already doing that work for me. I didn't have to actually prompt it. The Mondo terms we're interested in probably have an ID that starts with the Mondo prefix. So it's making a bad assumption there, right? Because this is going to be in the full URI, but it's still, it still found them, even though it assumed incorrectly what it was doing. So it's now extracting all the ontology terms that do not have ClinGen xrefs. But if I want to figure out how it determined that it was a ClinGen xref, I can go and look here. You know, it's looking for ClinGen. Again, my prompt could be different. I could actually give it the official recognized ID prefix of ClinGen. I'd probably have better results immediately, but look at how quickly I did that, right? Like I didn't write any code to parse. Sorry, go ahead.
Yeah, sorry to interrupt. I am very impressed, and Nico is too in the chat, so he asked if he could ask something. So Nico, perhaps go ahead.
Yes, please.
I have to say, I didn't know that you could do that. This is crazy. But have you tried actually so these use cases are all more kind of use cases along the lines of querying the ontology, but have you tried to actually try to add a new term or change a synonym and just obtain the results as like a pastable snippet into the text file?
Yes, definitely. So let me move on now. So yeah, there's some things you can do to write specific instructions. I could talk a little bit more about some tools. I guess the summary here, I'm going to get to your question, I promise. The summary here is that anything I can do manually with this tool, I can do with software faster. So our group is writing tools to interact with this, you know, the large language material faster. OntoGPT is one of those tools. I've linked it here. Basically, it says, you know, I'm going to feed you in any arbitrary schema that I write in LinkML, and I'm going to ask you to parse this text and return me that data from that text. It could be a set of pubs from PubMed. It could be a set of, you know, wiki data entries, whatever. And I'm going to have you put it back in the format that I asked you would in a schema, and it does so. And I can show you how to do that later. But can I create new ontology terms? Right, so that's where we're all getting to. We have these ontologies. We know they're extremely useful. Data modeling is hard. It takes forever, and it takes expertise, and it takes thinking, and none of that goes away with ChatGPT. But it can help you on your journey to make these new terms a little bit faster. So this one is right. So this is a user that has come into the relation ontology, and they have a new term that they're requesting. They've actually done most of the work here, at least in their opinion, to make this new term. And this is just going to sit here until somebody, some manual person comes along and says, okay, let's add it to the ontology, right? Unless they've made a pull request. And if they have, then I'm sorry, I didn't look into that. But right now it's just sitting there. It's 2 weeks old already. Most of the work is done here, at least according to this user. How can we get that to put in to an ontology? You can ask ChatGPT to do it. You can say, right, so let's see. This is the easiest example, right? Given the following text, please write me a ontology stanza in the format of an OBO file. I'm not using the right words here. I'm on the fly, right? So that's my first attempt at a prompt. I really want to get to the point that you see that this is an iterative process, right? So now it's going to try to provide me an OBO formatted response to this. And this one's really easy because, again, the user did most of the work, right? And they say, okay, you're going to have to put an ID here. Notice that it didn't hallucinate an ID, which I think is an improvement. It found the ROID, et cetera, et cetera. we can do better, right? So let's take the idea that it can make these things and let's make a tool that actually does that for you. And this is a very new tool. It's completely beta. It's Chris Mungel's tool, right? So, but basically you can take what we just did manually and turn it into code. And we can kind of look at how it works here in this Jupyter notebook. I'm not going to run the code for you directly, but basically it says, can we take an issue tracker? Can we take an existing corpus of text? It's our GitHub issue tracker for an ontology. Can we index it? Can we ground it in ontology development best practices? And can we get it to make terms for us based on the tracker? And it turns out, yeah, we can. We can look at the top 3 terms from our issue tracker that are similar to this term that we want to enter, right? So it's going to go over that corpus of GitHub tickets and it's going to find the ones that are closely related. It's going to tell you how far apart they are. You know, there's some technical stuff here, right? But you can kind of get down to the bottom here and say, right, so I can make a term right here, magnetosenophalography, using the content of those issues and ChatGPT directly. And I think what Chris is trying to say here is that, you know, if you just ask ChatGPT directly for this answer, it's going to give you one. It's easy enough to do. It understands enough and it has enough background information to give you definitions, labels, synonyms directly, but it's going to do a better job of it if you provide it with the context of expertise. And sometimes we can mine the expertise that we have in just our GitHub issues to do that work, right? So let's just do an even simpler one. So I work a lot on the BioLink model. One of the things that people have been asking for lately is a relationship in the BioLink. BioLink model is this high level sort of data model that is supposed to be a blueprint for, you know, comparing and looking at data across our ontological domains, right? So it has terms like gene and disease and really sort of basic biology. And it also has relationships between those things in different kinds of objects. So I know one of the things that people want are drug-drug interactions. And so I'm saying, so given what you know about the and BioLink model was written before 2021, right? So it knows a little bit about BioLink model. Please add me a predicate. That's what we call relations in the BioLink model for a drug-drug interaction. Include domain and range of the predicate. Format it in LinkML YAML. Add mappings to external ontologies. Let's just see what it does. I haven't ever done this one before. It's sort of on the fly. Okay, so let's see what it's doing. Interesting. So it got lots of it right. It gave me a place to go. It did something wrong, right? So here it's trying to make drug a type, and a drug in the model is actually already a class. So the first thing I would know is that my prompt is not specific enough. It should have already recognized that drug was a class in that ontology. Let's see down here, slots in the BioLink model are complicated. I won't go into it, but this is a predicate. This is the correct format for that predicate. It does give me some sort of description here, right? That's true. It does get the domain and range right of this predicate. It does get the slot URI correct-ish, although that should be a Perl. And then it gave me some mappings. And this one I know is correct. This one I have no idea. This looks like a hallucinated identifier. So I think that's probably something you've seen before, but the things that I like out of this, which, you know, spurs my creativity with this and being asks me to add a better prompt for this particular use case, is the fact that it got the LinkML syntax pretty well right, that it understands what I meant by domain and range, and it understands what I meant by mappings with literally no work on my part. I mean, it took me 5 seconds to add that. So I guess what I'm trying to say is that despite the fact that we know that there are tons of limitations and gotchas, I've showed you some examples on the fly here that weren't perfect. when we talk about using a large language model and iterating over a different kinds of examples, we know that, like, despite all of its bad things, it can actually really make you more efficient in some ways. You know, there's always going to be problems here. These models are biased. They're expensive to create, both monetarily and environmentally. They could, you know, lead us to this echo chamber effect where everything we found on the internet is just telling us more and more about the things we already know on the internet. There's copyright infringement coming up. You know, there's these face replicators. I put one in chat earlier, and while it's kind of funny to think about the idea that somebody could take my image from this, you know, this talk, put it into a face recognizer, a face generator, and, you know, make a completely different model of my face and put it out there, is kind of crazy to me and scary. But what I can tell you after all of that is that it does help me as a software developer be more efficient. I can work faster and longer on things that I care about and save the things that are really trivial, that I can easily check to something like a large language model. And I think that same thing could be applied to ontologies. There are things about ontologies that make them very difficult to create and requires a lot of subject matter expertise. If you already have that subject matter expertise in place, if you already have things that you know are easy to do or that can be done with code, but you don't have someone to write that code, I would encourage you to try it with ChatGPT and see if it can create you some code that you can put in a Jupyter notebook that you can just run and save yourself some time. So maybe I'll stop sharing there and see if there are any questions.
All right. Thank you very much, Sarah. This was impressive and always good to know about these developments. I certainly learned a lot. I don't know, does anyone have any questions to Sarah about this? Not here from the local audience. I don't know if anyone has on the chat or online. If not, thank you, Sarah, again. And I think you can go to Nico for the 2 last sessions. Yeah.
Sorry, I should just share the right slide deck. So, do you see the slides?
Yep, it is here.
Yep.
Excellent. All right. Good. Yeah, thank you, Thiago, for getting us all the way almost to the end. As some of you or most of you have seen by now, we have changed the schedule a little bit and made some adjustments. So some of the next pieces are a little bit improvised, but hopefully we can still get through them. So I'm going to pull us a little bit back into the obo ontology development world after we've now made a for me at least, mind-blowing diversion into what is going to probably dominate our, you know, revision of our methodologies in the next years with ChatGPT and large language models and generally generative AI. So I'm going to give you a brief tour through some of the key tools that we are using in our daily practice. We originally wanted to give a more extensive robot tutorial. I'm going to just briefly brush through robots so that you can get a sense, because I didn't prepare any specific materials for it, and I have to resort to some materials that have been created for an earlier version of this training here. And yeah, as I said, improvise slightly. So let's start though with talking a bit about managing the ontology lifecycle. I'm going to also create myself a little bit of a timer here so that I'm really carefully sticking to time. So as we've kind of like heard from many of the talks today, and in particular from Sabrina's introduction, when we are building ontologies is so what our primary goal is to capture relevant concepts of a domain for some specific use case that we want to use the ontology for, and capture these elements and the relationship to elements of other domains. So for example, before we've discussed the domain of diseases in Sabrina's talks, and we may want to capture information like relationships to things like genes that are related from these diseases or anatomical entities, for example. And we also wanted to do this in a way that is scientifically accurate and also logically consistent. So this speaks to this use of these formal reasoning techniques that Sabrina showed you a bit before when we are using the reasoner. So really the key part here for us is, yes, we can use the reasoner to automatically derive a classification, but the important thing is that also the reasoner will tell us when we say things that are logically inconsistent, where two pieces of information we provide in the ontology conflict with each other. So this is really, really important. So the goal here is to capture these interrelations, and these interrelations are captured using these kinds of logical axioms. So logically axioms in the ontologies that we are building relate entities from a very diverse set of ontologies. So this is just a relatively simple example here where we are trying to define the concept of hyperlysinemia, which is in the human phenotype ontology, in terms of a quality in Pato, which is decreased amount, and in terms of an entity, which is lysine in Kebi, and blood in Uberon. So here, this is basically a logical decomposition of this hyperlysinemia term. And a lot of like what we call ontology engineering is coming up with axioms like this. And this kind of brings us to a bunch of problems. To start with, how do we actually get those terms that we want, these building blocks to build our axioms? How do we even get them into the ontology? So we know we need to use blood, but how do we actually get the term blood from the large Uberon ontology into our ontology so that we can use it to describe this axiom? And secondly, how can we convince ourselves that when we make an edit, that we make a change, that we add an axiom, remove it, or change it, that we actually did not break anything, and we want to get some confirmation, yes, what you did is somewhat right. And lastly, how can we make sure that users after we are all done, we have created our beautiful ontology, we have created we've curated our all our terms the way that we want, the class hierarchy looks perfect, how can we actually provide this ontology in a standardized and fair manner? And Anita has given you a lot of ideas of how we are trying to promote and create more standardized and interoperable ontologies, and we want to make sure that these kinds of standardized, for example, properties or even file formats that we are generating, that these are going to be usable across the entire community and making our users happy. All right, so just a few words about dependency management. So when we are talking about dependency management, sorry, I've skipped a slide, unfortunately, so I'll go back. So the ontology development kit is actually two kind of different things. So it's, on the one side, it is a toolbox. We can't get into the details of what this means here right now, but a toolbox in this sense is we have a collection of tools that are frequently used for ontology development, including tools like Robot, like the ontology access kit, but many other tools as well that are kind of like that we use in our daily lives when we are manipulating and processing ontologies. So that's the one side. And the other side is we have a workflow system that allows us to specify the pipelines that we need to solve the problems I just described. So for example, how do we pull and import a term from an external ontologies, or how can we produce a standardized obo graphs JSON version of our ontologies, the one that Sierra just used in our example in the ChatGPT tutorial as well. So this is the kind of second part of ODK, which I will focus on here. So the first example of workflow is dependency management. So we have this, what I said before, you have your ontology, you know you need to use the word blood. And what happens is that what the ODK does is the ODK has like a bunch of repeatable workflows that are also configurable, and if you set it up, it can go and download all of Uberon, then pull the term that you want from Uberon, include it into a much smaller import module of Uberon, which itself is imported into your local ontology. And this system is designed in such a way that it always that you can rerun it anytime. So you can run a workflow called refresh Uberon. What it will do is it will go to Uberon, take the latest version, include the latest versions of the terms that you need. For example, let's say blood has a few axioms added or changed in the latest version of Uberon, then we are also going to get into the benefit of this changed changed term description. The second piece is continuous integration. So this speaks to this problem of you want to convince yourself that you didn't break anything. So one of the kind of big important things that we have been trying to push in the community is to make sure that no ontology that we maintain is ever going to be broken on the main branch. So the main branch in GitHub is always kind of like this branch where the latest version of your files are stored. And so what we do is what Sabrina told you before is you open a new branch, you make your edits there, you make your pull request on the ontology, and then this continuous integration testing suite, which is a lot of different tests is being run. And the ODK provides a very, very comprehensive set of tests that include some of the tests that are also executed by the OBO dashboard that Anita showed. Lastly, we have some pipeline for generating these different kind of release flavors, like different serializations, like OWL format, OBO format, JSON format, and different kinds of variants of the ontology. So all of these kinds of standard protocols on how to generate them. And the way that this is manifest, so the way that you would interact with ODK is, so you would go, so first of all, you obtain the ODK, the program, and you would ask it, given here a small configuration of my ontology where I provide some name and some acronym, for example, and a bunch of small configurations, like I want an Uberon import module, for example, please generate me a Git repository, a full structure that includes things like the editor's file, that is the one file that Sabrina edited before to make a change to the ontology, create a folder with the imports in it, and have a standardized place where all of the release artifacts that are produced by the pipelines are stored and also versioned through the Git versioning system. All right, so this was just a brief tour through ODK. There's a lot of acknowledgements. I'm going to skip over. You all have access to the slides. There's a nice paper, and there are around 104, unfortunately 103, because I overcounted one, ontologies that use ODK at the moment. Of course, many of them, or some will be stale now, but this is, I think, a pretty impressive cut of the proportion of the open biomedical ontologies, and it's maybe worth for you to look at if you're interested to building your own ontology as well. All right, let's jump over a little bit to robots. So before, when I said, okay, we have workflows that, for example, pull files from, that download ontologies and then extract terms from these ontologies and take the ontologies and transform them into a different serialization and so on. I made it all look like this is all some magic inside of the ODK, but indeed ODK is just a quite thin wrapper that is utilizing some power tools like robot, and robot really is the Swiss Army knife of our kind of profession as ontology engineers, and anyone who's building OBO ontologies or even any kind of ontology. So there's nothing in robot that is specifically reduced to OBO would try to learn and use this tool. Now I hope that I can just switch to a different to a different branch real quick here. There you go. Can someone confirm that you see the robot tutorial on the screen?
Yep.
Yes, we can see it.
All right,
Yep.
thank you. So this is a robot tutorial that has been written by James and Becky. So I'm not 100% familiar with it, but I browsed through it, and I want to just briefly give you a 2-minute walkthrough to this. As Tiago mentioned in his first slides, all of these materials are extremely detailed on obo-academy as well, but I just want to give you a bit of a sense of what robot does actually. So robot is actually the real tool that we use to develop what we call ontology pipeline. So it allows us to build automated workflows, to do these, to implement these kind of QC checks that I mentioned before, to allow us to do modular ontology development, where we have some ontologies importing terms from other ontologies, and more. And the interesting command, so the robot has a lot of different pieces of functionality, but I'm just going to briefly go through over some of them so that you get a little bit of a sense. So here, these are merge, reason, annotate, and convert. So these are the ones that basically we use every day as ontology engineers. So merge is a command that basically takes in 2 or more input ontologies and just merges them together and outputs a new ontology. So there's a simple command like this: robot merge input. So there's multiple inputs and then generating an output ontology. You can also declare whether imported ontologies inside of these imports with the OWL import statements should be merged or not. Then we have some commands like the reason command that allow us to do things like logical validation. So I said before, one of the key things of importance for us is to really make sure that when we make an edit that we didn't introduce a logical mistake, a logical inconsistency. So this reason command, we can run it after we finished our edit on our ontology to make sure, yes, everything is still consistent and there's no contradictions. And we can use this command, of course, to automatically derive the classification. So if you remember from Darren's presentation, some ontologies really are purely driven by reasoning. So you have some very nice axiomatic structure that is defined using a design pattern, and then all the terms are imported from external ontologies. You run the reasoner, and then all of the classification is going to emerge based on the classification of those imported ontologies alone, and you don't actually edit anything manually. There are many reasoners implemented here. And yeah, we have commands like annotate that allow us to go and say, okay, I have my ontology, please add a version IRI to it, please add an ontology IRI to it, which is obviously something that we use a lot in ODK when we are generating our release products. Similarly, the convert command that will allow you to take an input in one serialization and output it to another. So one thing that I should have said before, this is occupational blindness. More clearly is when we talk about software. So today we looked at a lot of tools that were like UI tools where you have a program that you open, you have some windows and you interact with it. Robot isn't a tool like that. So robot is what is called a command line tool where a bit similar to maybe what Sierra showed before with ChatGPT, but where you actually go into your command line. So in your terminal, if you're on Unix, or in your CMD if you are on Windows, and you write these kinds of commands out. So sorry that I didn't mention this earlier, but in any case, all the functionality all the same. Yeah, and this was just another example here of a command that is run. So I think this is enough for now to get a sense. So robot is used, take some ontologies as an input, do something with them, manipulate them, alter them, and put something out on the other end. And we can really do really powerful things with them, including also combining these commands. So I can say first annotate, then convert, and all of this stuff in one single command. and combine this to really complex operations. So if you're very keen on like really building really powerful pipelines, then this is really the tool you want to use for this. All right, so much for robot. Let's make sure that I have enough time. Yep. Yeah, so lastly, I just want to briefly touch on ontology access kit. So far we have focused on tooling that is used to manipulate ontology, so that where you take, this is usually part of the editorial process, you take it, you change it somehow and process it so that it can be consumed by downstream users. Here, this is a tool where we are actually concerned with how can we actually use the ontology. So how can we access information in the ontology, like for example, the labels, the deprecated classes, the relationships that are in there. And this is the purpose of the ontology access kit. So ontology access kit is two things. So again, we have a command line interface that is similar, looks a bit similar to something like robot that I showed before, where you can install oak as part in your terminal, in your Unix system, for example, and then you can run command like this command here, give me, based on the Flybase anatomy ontology, FBBT, give me the tree for this particular term and give me all the ISA relationships. So you can get this printed out to your terminal output. Similarly, there's also a corresponding Python API that allows you to access this kind of information directly. And there are many, some would even be very mean and would say too many functions that you can use in Oak. It has things like looking up, so term lookups, I just described them, but it has stuff like, doing semantic similarity, which we've done a lot of work on recently. So you take an ontology and you compute how semantically similar are two terms. There are functions for visualizing parts of the ontology in nice plots. For example, they look like this here. So you want to know here, in this case, provide me a visualization of the ISA and part of structure around the memory T cell, and it will give you a nice picture that you could put in an issue to communicate, for example, problems in some modeling or something similar. But there are also functionality for lexical matching in there, for annotating text with ontology terms. So there's a myriad of cool stuff that you can do as a ontology user. All right, that was Oak. So now let's switch gears. I have only about around 15 minutes left now. So I want to get to this subject of open science engineering. So this is a real gear switch now away from the kind of like technical underpinnings of the work we are doing, and more shifting our attention to the wider community aspect of the work, and the kind of like practices around those concerns. So the first thing that I really also want to kind of as many of you that are maybe just starters in this area, that I want you to understand a bit is that these things like open science and open data are really catalysts, very important pieces for tackling global problems such as rare disease, pandemics, climate change, and so on. So these kinds of efforts that require really coordination of very different data generators and countries and governance structures and so on across the globe, they are absolutely pivotal to dealing with these issues of our time. And while opening and just providing the data in an openly available manner is a really great thing to start with, and we are really only in the very early stages of having all the data we need for tackling these problems accessible at all, it's really not the hardest part. Like, the hard part is really if we want to interpret this kind of information We need it to be in some kind of computable, standardized form that enables us to integrate this information. So we were hinting at semantic data models before. So Sierra mentioned LinkML, for example, but also common vocabularies and ontologies that are used across the world so that we can describe entities in the same way and make sure that we all understand what we mean by things like Marfan syndrome or any other kind of disease denominator, even if we are in a different country and we translate the value and so on. So we really take the position that non-standardized data without semantics is really not that open. So even if it's like openly available, and we consider this kind of work that we do, open ontology work, really part of the wider open science and open data initiative that are absolutely indispensable. Yeah, open ontologies, as I said, play a central role in open science. Standardization of data, part of the global data integration effort. So we have lots of different kind of scientific databases emerging across the world, and it's the role of us of building kind of vocabularies, ontologies that have explicit semantics to connect all of these databases that are emerging across the world together. We want to, we need to capture this kind of knowledge using well-defined semantics so that we know and can capture things like, is the heart part of the cardiovascular system? This kind of information should be emerged and should be agreed on and embedded in our knowledge representations. And we should be able to use all this stuff to do advanced data analysis and aggregations, like, for example, figure out which patients had a disease of the cardiovascular system, even though we don't have this specifically declared in the data, but we have, for example, someone with tachycardia or something like that. So I'm not going to show this slide because now I'm super worried that I've misunderstood something about ChatGPT, which I have been using for the past, I don't know, 6 months without realizing that it may have collected about me so much information. But I asked it, what are probably the most important pieces of technology for that facilitate global open data integration? And it said first blockchain, which is something I don't care about. But secondly, semantic web and linked data. But now I'm not sure whether I can trust it with these kinds of information because it knows probably too much about me and wants to please me and my my own sense. But maybe if one of you wants to repeat this question and figure out whether it still agrees with this or whether it's saying something else when you ask this question, I would be glad to hear it. All right. All right, so we've established we have a need for ontologies. We need this for global data integration, and for ontologies to actually be able to fulfill this role as like pieces of the puzzle for global data integration. One of the core things that they need to be is community driven. So for example, this is a really nice story. The story of Uberon, the species, let's say, independent anatomy ontology that was first conceived by some people around 2009. So describing some anatomy and their interrelations. And after some years, and it actually a lot of years, like it's not a thing of like 1-2 years. These are really some slow growing processes. You see that, you know, some external groups start like, and adopting this as a standard, and they start contributing to it, adding terms, investing a bit into the curation, and then you see, boom, suddenly lots of different groups start being involved in the curation of an ontology like Uberon. You see big projects like Human Cell Atlas and HubMap and Cell Annotation Platform, and all of these suddenly being invested in the ontology and contributing to it. But the problem is, the more kind of community or coordinated a ontology is, the more disagreement and the harder it will be to resolve certain disagreements. So for example, one project might say, I need these specific terms. Another project would say, these terms are totally out of scope for this ontology, and so on. So there's suddenly a huge need for coordination. And here is where this kinds of collaborative mindset of what we refer to as an open science engineer comes in. So an open science engineer in this view contributes to the collection and standardization of publicly available scientific knowledge through curation, community coordination, and data ontology and software engineering. So here I emphasize community coordination because it's really a key piece in the puzzle of standardization, to have people out there that are really, independent of whether they're actually building ontologies or not, that are looking to coordinate these kinds of conflicting issues and figuring out what to do when they arise. And so as for practices, so this is just like a fraction of the kind of like practices that you will see when you are dealing with issues like this, but I'm just going to hint at 3, which is the practice of collaboration, upstream fixing, and no ownership. So you can read more about these here at these links. You all have access to the slides if you're interested. So for the practice of collaboration, we have like, some cheesy sounding, but in the end, extremely essential suggestions, like be positive and generous with appreciation and attribution. So for example, when a user opens a GitHub issue that you don't want to address, you don't just close it and say, I'm not addressing it, but you're a bit more appreciative. You say, you thank the user for taking the time to write this issue and explain why it's not possible to address at this time, and so on. So really like making it much more clear in your mind that building a community is about being respectful to others. So recently we had a case, for example, where we were, writing really bad Git commit messages and Git messages and Git pull request descriptions, and this is really making life for other people that are maintaining these projects much, much harder. And this is another sign of respect to others. If you take a bit of care, if you're contributing such things, issues, commits, pull requests to a public project, to really be careful with how you phrase them. Then we are trying to together to improve open science documentation. So for example, projects like OBOK, they start as a grassroots project with like some crazy people coming together and saying, I will contribute this piece, that piece, that piece. But in the end, the only way that these things can grow and scale is if all of you go and contribute to these resources, add their pieces, fix issues, even if they are typos, and everyone can fix a typo or add a link or fix a broken link, and so on. Yeah, so let's move on forward. I need to skip over this because I'm seeing that the time is running short. The principle of upstream fixing, this is another very, very important issue. So people in our world, especially engineers, tend to have this thing that I need to fix this real quick. So they import, for example, a term from an external ontology, then they realize there's something wrong with this term. For example, there's a typo, there is some wrong annotation or something on it. And what they do is they add a robot command, one line, saying delete this term or change this label or something like that. This stuff is super easy now. And that's it. They fix it on their side. But one of the principles of like open science engineering is really, and this is kind of like, you should really hammer this into your heads, like upstream fixing means if you spot an issue with something that you're using that is benefiting you and your project, that you're using from someone else, and you see it, go and make this extra effort, even if it's like an hour's worth of work, to write an issue somewhere else and say, guys, there's something wrong here. I just wanted to let you know, please to fix it. So this is kind of like, we want to push changes in the open science world where everything is so heavily interconnected. I didn't go over this slide, but this was to make a point that all these open science projects are interconnected. We want to push the problems up to the source so that everyone down the dependency chains can benefit from the fixes, even if they are tiny things like fixing a typo. All right, and the last practice here is the practice of no ownership. So there's a lot of kind of, you know, this, especially in the world of engineering, there's a lot of this sense of I wrote this tool, I made this ontology. So people get really like invested in these things, and I think it's this is totally normal, especially when ontologies emerge, and probably for a long time after. But at some point, when ontologies broaden up and the community gets involved, it's really important that we get a sense that there is no such thing as ownership. Like every breath we take as open scientists is paid by the taxpayer. There's not really any kind of like reason to say, oh man, it's mine, and this is mine, and comes from my genius and my hard work. But it's really like the whole world that kind of contributes to all of the stuff that we are doing. So getting a bit more of a sense of that we don't own these things, and that we should, you know, not just invite others to add to our tools, but really when we see problems with other tools, or we want to help other tools to flourish, we go and contribute to those tools as well. So really go and reduce your fear of interacting with others. And Sabrina was mentioning before also, you know, we have all these facilities now that you don't need to be afraid anymore. If you contribute to other repositories that are not yours, even pull requests, you won't break anything. Everything is completely under some standard operating procedure and will be tested with quality control. All right, so I'm going to skip through this tools slide here. I've wrote a big kind of like section on the kind of my favorite tools that I think everyone that is an aspiring open science engineer in the area of biomedical ontologies should look at and master, or at least to some degree understand. So I just want to leave here with the last two slides. So the first steps that I would suggest if you're new in this journey towards open science engineering is everyone, absolutely. There's no, even if you're a community coordinator, it doesn't matter. If you're a non-technical person, you do need to at least a GitHub account. Do get extremely over-exaggerate the way that you go out there and spread love, like people's work, put likes on people's comments and issues, really show them that you read the stuff, that you appreciate what they're doing. This is the fuel on which much of the open science movement is based, and I think that this is the cheapest way to pay this back. Complete a basic ontology contributor training. This is an extended version of what Sabrina has started to teach in this context here. And make a pull request to an open OBO ontology, even if you don't care, just for practice, just do it. Look and master the open this ontology tool belt, and also join some kind of an open
Nicholas, suddenly we cannot hear you anymore. Not sure what happened.
Sorry, do you not hear me?
Oh, yeah. No.
When did you lose me?
I think
We
just
lost-
the ontology belts, the ontology tool belt.
Ah, sorry. Okay, and lastly, join an open data project and offer your help. It doesn't have to be an organization like OBO Foundry, but OBO Foundry and other organizations like this, they all look for people at all times. But it could be just an ontology you find interesting and you just want to say, I want to contribute. I don't even know how, but I just want to help you with stuff. Just reach out to them and just get involved. All right, so today was a good start, I think, for this starting this journey. We learned about the OBO dashboard. We learned about ChatGPT. We learned a little bit about robot and about Protege. And I hope that this journey is not the end for you. So I will just want to invite you to join the community to tackle the global challenges of our time, and yeah, in the name of all of the kind of contributors for today's tutorial. I just want to thank you for your time. I'm really sorry we didn't actually have time for an extended discussion as promised, but I will stay here for the next 15 minutes if people want to ask something. But I understand if you have to go, of course, that's the end of it. So passing back to Tiago, and thank you for that.
Yeah, thank you very much, Nigo. One thing that I actually forgot all this tutorial was to thank people with claps. So let's get a round of applause for all the speakers and presenters today. It was really good. So, yeah, appreciation is always good, right? And yeah, Sabrina's reminding there's the obo-academy that you can all follow different aspects of the tutorial. We didn't got extended discussion, but I am sure that everyone in here will be happy to answer your questions and help you get inside the different OBO Foundry ontologies. There is an OBO Foundry Slack where people are super helpful. So if you're interested in that, just get in touch with me or any of the others. And that's pretty much it. So have a nice night, day, or whatever you are in the world. Thanks.